In classical computing, we store information in ones and zeros, whereas in quantum computing, we use particles. So like an electron might be used depending on what state it's in, depends on what information is being stored. A quantum computer costs 10 million euros to build, and that's not including the maintenance and the upkeep of it. The abilities that we have within quantum computing should be accessible to any student or any researcher that wants to explore or innovate in that area. Munster Technological University is a hub for cybersecurity, it's a hub for innovation, so this is a really great environment for quantum computing. The QCloud project provides free, scalable access to quantum computing for any researcher in Ireland. Rackspace had had a successful EOSC funding before, so they were quite familiar with the process. This QCloud project sets a method that other countries can look at for providing quantum computing to researchers. Rackspace Technology were there all the way through. No matter what we needed, they were able to provide it or find someone that could provide it. Rackspace really made it achievable, broke it down for us, and gave us the skills needed so that we could maintain the project ourselves going forward.
The QCloud allows Irish researchers to gain access to real quantum computing. Each time we say we are accessing quantum computers, what we mean is we are using Amazon Braket. Amazon Braket is the quantum part of the cloud-based Amazon infrastructure.
AWS actually offered free training for all of us here in MTU, so we were able to upskill as AWS Cloud Architects, and that meant that we had the capabilities to actually host this environment and maintain the infrastructure and add projects. What Rackspace built for us was firstly a landing page where, from the Munster Technological University point of view, we have oversight of all the different projects, what the access controls are for those projects and who has access to them. The Quantum Ed project is focused on undergraduate and postgraduate education. What we're trying to do is develop a suite of resources for quantum computing education so that it can be placed into multiple different disciplines, so that any student coming out of those 4 disciplines has at least a fundamental understanding of what a quantum computer is and how it might work. Rackspace helped us come up with the vision of how QCloud would work, and they also built that vision for us. From the very beginning, walking us through what the funding proposal involved, how we could write it, what a national infrastructure would even look like, and then even through to the realization and the building of that infrastructure, Rackspace was at the heart of that. Going forward, any new research project that's coming on board will be able to become part of Quantum Cloud. No matter how small or big, whether you're an established quantum researcher or not, you can become part of QCloud and get access to quantum computing and also our upskilling that we're offering as well. It puts us on a world stage in terms of the infrastructure we're able to offer, and it wouldn't have been possible without Rackspace technology.